You added more servers, but your system is still slow. Something else is now breaking, and that something is your database. In the last video, we scaled our system using a load balancer. Requests now go to multiple servers. But look closely. All those servers are still talking to the same database. And that's the problem. The database is handling everything: reads, writes, every request. As traffic grows, query starts waiting, responses slow down, and eventually things fail. And there's a bigger issue. If this one database goes down, your entire system goes down, even if something else is working perfectly. So, what do we try first? We make the database stronger. More CPU, more RAM, bigger machine. And yes, it works, but only for some time. You can't scale one machine forever. And it's still just one database. So instead of one, we use many. This is called database replication. We create copies of the database, one main database and multiple replicas. Here's how it works. All writes go to the primary database and reads are distributed across replicas. Now you might be wondering, how does this data reach all replicas? In most systems, the primary database directly sends data to all replicas. So whenever data changes, it is copied to every replica. But in some systems, replicas can pass data to other replicas. This is called chained replication. It helps reduce load on the primary database, but introduces more delay. For now, we'll focus on the first approach, since it's the most commonly used. And one important thing to remember, this replication is not free. Every write now has extra work. Data needs to be copied across multiple databases. So while replication improves reads, it also adds extra complexity and overhead. But there's something interesting here. Let's say you update your profile and then immediately fetch it. You might still see the old data. That's because replication is not instant. Data takes time to reach replicas. This is called eventual consistency. Now you might be wondering why this trade-off exists. We'll break this down in a dedicated video when we talk about the cap theorem. So what did we achieve? Reads are now faster, load is distributed, and the system becomes more reliable. But we are not done yet. All writes still go to one database, so the write bottleneck still exists. Before we go further, there's another important layer that is called as caching. Instead of hitting the database every time, we store frequently used data in a faster layer. This reduces the database load and improves speed. But for now, just know that caching exists. We'll go deep dive in it in a separate video. But even after all this, we still have one big problem: writes. To solve this, we take the next step. Instead of one big database, we split the data. This is called as sharding. Now, different databases handle different parts of the data. All writes are distributed. Instead of one overloaded database, we now have multiple smaller ones. But this comes with its own challenges, and we'll break that down in the next video. In system design, fixing one bottleneck creates another, and that's how systems evolve. See you in the next one.